Okay. Now, what we're going over today is terminology specifically related to the term route add. What is it? Why do you care? And how does it relate to you? And then a whole mess of tools and suites of tools that help you understand what routing does, okay? And how you move stuff back and forth and move it around the net and so on and so forth, okay? So this is, again, another way to help get terminology worked into your psyche with networking. Because to be effective in networking, you need an awful lot of buzzwords. And you have to kind of know how they all fit together. Okay. All right. So start with, rather than me jumping into the deep end of the gate here, or deep into the pool, what I want to do is explain to you what route add does. Okay, we'll start there. And what I'm going to do is I'll just boot this Kali distribution. This is a live, which means it boots from an ISO image, and you copy the ISO image into your a pen drive, and then you boot from your pen drive, and you've got basically a mobile distribution of Kali available on your pen drive. Live distros are really handy. It's kind of neat to put it on an actual CD and boot an old computer and configure everything in RAM, just like a router. So when you reboot it, you reconfigure it, or you save it to a pen drive for all your configuration, and off you go. Now, let me ask this question. Can you see very well the screen share? Is it viewable well enough? All right.
Yes.
Okay. All right. Because what we've got is, let me go into root terminal here. So what we're looking at here is a Kali distribution, and I recommend you download it and play with it. It's definitely worth your time, and there's so many tools that you can use in your job for future reference. Okay. Now, since this is a live distribution, I can do things to it and reboot it, and it will hopefully do its thing. Okay. So I'm going to use a pair of commands called IPA. And IP, this is the whole suite of tools in the IP suite, and all these different things tell you different things about your TCP IP stack. So when I type in IPA, I could type in IP address, but since I'm lazy, I only have to type enough to make it unique. So it knows IPA is going to give me an address. And if I type in IP label, so I need EL, and it says, okay, what am I doing? So you look at man and figure things out. But here's where we're going with this. How many network cards do I have? Every computer you work on will have this one. This is the Loopback. And those of you that made it to the cable making, there was about 3 of you that showed up, which is good. It was actually more than I expected. The Loopback allows you to check your physical network card. There's a Loopback connector that you used to be able to use. You'd plug it into the back of your network card, and it would actually do a Loopback for you. And so you could send a packet out, and it'd it loop through the connector and then come back to your NIC card. So you could verify that your NIC card was working, okay? Well, modern network cards have that built in. So when you ping Loopback and you do something like this, ping 127 dot, which one have they got here? They've got it set up as 0.0.1. And you can see I'm pinging it. What am I doing? I'm actually going out my own network card and coming back to my own network card. I am actually not anywhere on the cable. So I'm not connected to the cable, okay? And Loopback is the beginning stages of making sure your card is working. And every card has a Loopback. This is kind of how you bind the software for the TCP IP stack to your device, okay? So I notice it says ETH0. Well, that's my first network card I have in my computer. So if I ping that, which is this IP address here, okay? And if I type in ping-count4 and paste that in, I'll get 4. And you can see I'm actually pinging my own card now. But let's look at that pfsense thing. Notice what my IP address is. Okay. We're going to pause, and I'm going to explain something here. When you use a virtual machine arena, like VMware Workstation, or VirtualBox, or KVM, or Zen, or QEMU, whatever, Microsoft Hypervisor, they create a networking stack for your virtual machine. So what am I doing here is if I look into settings, you can see I have a network adapter. And it's natted, but it gave me a internal IP address, the 192.168, okay? So when I create virtual machine and I select NAT, it's going to allow me to go to the internet as just like you have a Linksys router. You have a Linksys router at your house or some sort of a router. You can ping each machine in your home network. If you haven't done that, do that. Learn how ping works. And ping the router. And you can see how your network's set up, okay? And what we're going to do today is hopefully explain how route add works in this idea. Here's the big picture. Route add allows you to send traffic to individual network cards. So let's say you don't have a way to get onto the internet. You're borrowing your neighbor's wireless, okay? You have a wireless card that's connected to your neighbor's his wireless. He doesn't know, he hasn't changed the passwords. So you're surfing for free off his dime. But you want to set up a network in your house that can work off of his router. And this is what route add will allow you to do. Okay. So the way route add works is I want to take anything that is not on my 192.168 network and route it to the wireless. Everything else stays internal. Okay. So you can set up a 60 machine internal network, and anytime one of them needs to go to the internet, they connect to your machine, which is the gateway that connects to the wireless, and it comes back. And if the fellow is running any sort of forensics on his router, he will say, hey, there's only one machine ever connected from my neighbor's house. Oh, no big deal. When in reality, you've got 60 machines connected through his network. Okay. This is what route add brings to the table. Okay. So what I want to do is kind of show you how to set some of this stuff up using some free stuff that's available to you. Okay. So what I'm going to do is I'm going to add a network card here. I'll have to bounce my box and change it. This is going to be I don't want it bridge, toast only. Private network shared with the host. Actually let's see, what do they have for LAN segments here? Okay, we'll try this one. This may not do what I want, but we'll see what it sees. Okay. So there it is, host only. And notice what it's doing is it's basically rebooting. And if I look at my cards, look, all of a sudden I now have a new thing. Notice what I got here. I have a new subnet. Okay. All right. So I have a secondary subnet. So now this Ethernet 0, I can do this. Go back into my settings. Ethernet 0 was the first card, this one. And I'm just going to disconnect. Okay. So it's not on. Okay. And I may have to yep, it's down. Okay. So you see that my Ethernet 0 is gone. And if I try to get to the internet, this might work. I don't know. Nope. Not going to work because I can't get to my other thing. So let's look at this. Let's go to 8.8.8. Yeah, I can't get out. I'm stuck. I have nothing. I have a IP address, but I cannot get it to anything else because I don't have a route out. Okay. I have my local, my host only network. Okay. So I've got one network card. So let's go over here to my pfSense here, play some games with it. And I am going to add a network card as host only. Okay. Now, I will probably have to reconfigure everything, but that's okay. Doesn't take that long. Now, before I get too deep into this, let me show you what I'm talking about here. What I did is I did a very strategic Google search, and I was looking for Linux router firewall distributions. And I just wanted to find a list of them because I'm familiar with several, but there's a lot in this list that I didn't know about. I go, oh, this is good. So just because you think you know doesn't mean you know. And information like this changes quickly. So when anybody says, yeah, I think I'm pretty good with IT, you might want to check, because somebody who really knows IT says, I still have a lot to learn. And I say that every day. Okay. So what these are, let's explain what these Linux firewall are for. Pardon me. Let me turn that off. What I have here is a list here. Okay. Now let's explain what these are. Linux router firewall distributions. Basically, you get an old piece of hardware, like a computer, and you get a secondary network card, and you load these operating systems on it, and you have a free high-end router, firewall, VPN server, blah, 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 blah. All kinds of things that you can do with an old computer and 2 NIC cards. That's what this is about, okay? And then they tell you which ones are available, which ones are not available, and which ones are good and not so good, according to this opinion, okay? This one right here, I tend to like because VYOS is very much like configuring a Cisco switch, okay? You have to know the menu structure of configuring how to configure it. And yes, there's no web interface. So learning how to do the command line, it's hard to automate a web interface, but a command line is easy to automate, okay? All right, so here we have, only if you have 10 years of command line. That's kind of not so true, but you do kind of need to know what you're doing if you're going to make any Linux distribution as a router firewall. I don't recommend that, okay? These are what you would have to pay for. You know, they're encumbered somehow. And these are some things that, these are the ones that you can play with. And I highly recommend playing with some of these things. If nothing else, read the documentation, because it will give you another way to understand networking, okay? And it's BSD, so that means it's either FreeBSD or NetBSD or OpenBSD. And a very strong community. This one's been around a while. This one you can actually put on an actual router. You can actually put this on a Linksys router if you have the right kind of Linksys router. There's limits. Once Cisco bought Linksys, they said, we're not going to let you do open source. And there was such a cry from the community that said, okay, we'll just make one model that's open source that you can hack. Okay, so that's kind of where that went. And pfSense has been around a really long time, and it has fantastic documentation. And as with most of this stuff, they're in the business of white boxes. They optimize software so you can put it on basically any kind of hardware you want, so you can customize it the way you want to customize it, okay? All right, and there's another one. These are firewalls, and they give pros and cons. But the things I'm playing with today right now is pfSense, because that's the one I'm familiar with, obviously, because it's been around a long time. And it's built on BSD, which I kind of know, okay? So we'll be playing with that one a little bit. So those are some tools. I'll add that link to the notes after we get through the lecture, okay? So what I want to do now is I actually want to reconfigure everything, because I've added a second card. And I want to reconfigure it all. Now, promiscuous mode is, you can enable promiscuous mode in a virtual machine, but you have to go to the VMware website and do some magic at a very low level, okay? It's outside the scope of this class, okay? But for the most part, if you're running on native hardware, like you have an old PC with a network card that costs more than $5, probably the one that's built in, it will support promiscuous mode. Promiscuous mode is what allows you to run Wireshark. So you can capture all traffic that's going on your net. And that's actually a good place if you have the right tool chain, is you can put Wireshark on one of your routers here and actually kind of have some fun with it. Okay. So you can actually see your traffic in your entire house. Okay. All right. So there we go. Now notice what we have here. I've got, you can see that I have two network cards now. I have a LAN and a WAN. Okay. So what I'm going to do is I'm going to just drop into a shell here, 8. Okay. And here's my shell. So let me do this, echo $shell and see what kind of shell I'm running. Okay, I'm running shell, which is SH. It's probably dash or ash, which means it's not bash or Z shell or C shell. This tells me I know what limits I can do with my programming when I start scripting up my shell scripts. Okay, so here I have it. So let's do an IPA. Command not found. Oh no. So let's see if they do if config. And there they are. So they're using the older tool chain of if config, not the newer one, which is fine. All right. So you can see that my EM0 is connected to the 79.132 and EM1 is 168.1.1. Okay. So one of these is my router and one of them isn't. So here, I'm going to try something here. Do ping. And I will do C4 8.8.8.8. Now, before I hit enter, do you think this will work? This is how I try to learn new stuff. When I'm learning new stuff and I'm trying to learn it from a book or a cookbook recipe off the web or whatever, before I hit enter, I try to think through what's going to happen after I hit enter. This is also a great way to help your programming chops. Okay. Okay, I'm going to run this. What's it going to do? Okay. So my vote here is I'm going to ping 888. And since I'm on my router, which is running pfSense, it's going to work. And lo and behold, it does. Okay. So let's go back to my Kali Live here. Remember my Kali Live, and the default password for Kali is you log in with Kali and password Kali. Okay. And now it doesn't work. But let's check something here. Okay. Let's do IPA and double check. Okay, I've got 191, 128. Now let's see which two addresses that are available to me here. So let's do ifconfig here. -A. And I have 192.168.1.1. Now, what you will see, I can't make the mouse work. I wonder if what I want you to notice is, notice where it says inet 192.168.1.1 net mask 0x FFFFFF00. They're displaying it in hex. What is that in decimal? 255, 255, 255.0. Okay. This is a BSDism. They do more with hex when they display things. Okay. So I have a /24 network on the 1.1. And let's see what I have on, I'll run it through less here, which is a pager. And EM0 is 179.132 FFFFFF. Okay. So let's see what happens here. So I have 79.132 and 168.111. I'll go back to Kali Live here. See if I can ping 192.168.1.1. Nope. And the other one was 79.132, right? Nope. So I cannot get to it. Why? My IP address is on a different subnet. Okay. So I cannot get to pfSense here. All right. Now let's do this. Let's take Kali Live, go to settings, and I'm basically going to turn this one back on. So notice my 179.130 is now back on. So watch what happens now. What's your bet? Yes or no? I hear yes. Almost. I may have to reboot because it says, wait a minute, I'm losing all my packet. I can't get to it. Let's try that 1.1 thing, see what happens. Whoops. Can't get there either. I might have to reboot. Because sometimes when you, this is like taking a network card out of a running machine and then plugging it back in. It causes problems. So I'm just going to reboot my Kali so it reloads the stack and goes from there. Okay. All right.
Would renew also work there, or do you have to reboot?
Renew would work on Windows if all you did was change the IP address. Okay. In this case, I actually could have done system control network restart. I could have done that. And the same with a Windows, you can basically bump start it. But the release renew in the world of Windows is primarily to release your IP address from DHCP and get a new DHCP address. Okay. What I basically did was pull the network card out of a running machine, okay, by disconnecting it. Okay. Because in the VM, when I go into settings, that's kind of what I'm doing. I probably should have ran it from the command line and done the same thing from the command line, but that's okay. All right, so let's look at IPA now. So now I have my two IP addresses. Okay, now let's see what happens when I try to ping. I don't have any history, so it's a live distribution. So I'm still not getting to it. Okay. And one of the things I need to check on pfSense is the firewall set up in such a way that I can't get to it? Okay. Ooh, let's do 14. Let's do that. What is SSH? Well, it gives you the ability to log into this machine at the command line. So what I want to do is actually do number 2. And I want to change the LAN to see how I have 191, 128? I'm going to use 191, 130. Don't remember that. 192, 191. 191.130. Okay. And we'll use 24 as my subnet mask. And the gateway address is going to be the one that we had here. What was that was? 79, I think it was 132. Whoops, backspace doesn't work. Stop. 130. Enter for none. No, we'll use fixed IP for right now. I'll say no. All right. So notice what I just done is my WAN is on 192, 168, 79, 132, and the LAN is 191, 130. Now, my LAN over here in Cali Live, 132. Oh yeah, 79, 132. And then I got 191, 128. So what I want to do is bring that first one down. Because I have config loaded? It is, okay. ETH0. Down. See, this is another way to do it. So now if I run IPA, you can see that it's down. Ethernet 0 is down. And notice it still holds on to the IP address, but it's not going to do anything with it. What I want to do now, I'm testing between this one and 130. I want to see if I can get some connections working here. One 191.130. Haha. I can now ping my pfsense. Now let's go back into my shell here. And I can ping pfsense back to the Cali. So let's do ping count 4, 192, 168, 191. I think it was 128. Yep. There we go. Okay. So I have connectivity between my Cali Live and pfsense. Now I need to verify that I have or don't have a gateway. Now, in your test out, they talk about gateways. And that's exactly what they do. They are a gateway. They take the traffic and route it through the gateway to the next hop. And the way you view gateways is you use a couple of commands, and they have slight differences based on the platform you're using, okay? Netstat is one of them. And you say RN, and then you can say, where's my gateway? You look for the letter G. Notice it says destination default. It says the word default. In the world of Windows, you will see 0.0.0.0. It's the same thing. In Linux, you will see either default or 0.0.0, depending on your distribution in the toolchain. Okay. But you notice, look at all the things that I have here. I only have one gateway, and it's tied to the IP address of 168.79.132. That's the one. Which one is that? I've got 2 network cards. Which one's what? Let's take a look. I'll show you what I'm talking about here. NAT is the one that has the 79.132. This one is the 191 that I set, okay? 191, whatever, 192, okay? So now so I can ping both ways now. I have a gateway. So let's go over to Linux or my Kali here and see if I can ping my default gateway on the other machine, which is 79.132. Is that right? Did I get that right? 168, 179.32. Yep. Well, guess what? It's not working. What's this mean? So let's look at netstat minus RN. Do I have a gateway? Is there a gateway on this machine? Do you see the letter G? No. I have a gateway. The 0.0 default, it thinks it wants to go here. But guess what? I don't have a gateway. I have not configured this interface to have a default gateway. Okay. Well, I guess I did. It's 0.0.0. But what I need to do is change that gateway. And this is where we do the route add command. Okay. Now, watch me blow this up 15 times, because this is the type of thing that you do and you write it down and you forget. You do, you write it down and you forget, because you don't do it that often, unless even if you're in networking, you don't add static routes all that often. Okay. That's what we're doing. I'm creating a static route. Okay. And what I want to do is I have some notes, but here's some notes that work off a Linux box. And basically what this is doing, this one right here, is saying, if it's anything 10net, go to Ethernet 0. Okay. And this was the default gateway I set up at the time. If you want to go to the default, go out this network and use this controller. Okay. So we are going to try a variation of this and see what we can come up with. Okay. So basically what I want to do is I want to do something. Oh, I can't do it that way. I have to go up here and say edit, paste. All that. Try that again. Right click, copy from there, here. Look, VM. No, edit. There it is. So I want to go out my default, which is ETH1, and I want it to go to what was my IP? 192, 191. Route add network netmask. I want my current IP address, which is, what's my current IP on this one? 130.
Is it the 79.122?
There we go. This one is 128. Okay, those are the two I need to remember. 128. See, this is where I'm fuzzy. I can't remember which one I need here. Okay, my route is added. So let's see if I can ping this IP address. Oops. No, not yet. So let's do netstat -rn. The guys that know how to do this really well are like Scott Fernandez. He knows this stuff backwards and forwards. I keep forgetting. Since I have, there's a gateway, local gateway. I think I actually need the IP address of the other card. Okay, now I've got two in there. Now I have to do a route delete. So I can do that. Let's see what happens here. No. It was 132, right? Yeah, 79, 132. 79. Oh, wait a minute. I think I'm putting the gateway on the wrong machine. I think I need it over here. Because I have a gateway for 132. And, oh dear, who's 130? Oh. Okay, I see what I'm doing. (191). There's no gateway on the 191 subnet. Okay, that's what it is. So what I need to do is on my pfSense is that I need to create a gateway. So I'll just type it here so you can kind of see what I need, is create a gateway between the 192, 168, and 79.132. And the other one, 192, 168, 191 dot 132. Okay, because I'm on this particular machine.
I think it's supposed to be, is it 128 for that one?
Actually, 128 is the Cali Live IP address. Because if you look in the chart here, if I do,
Oh, okay.
yeah, if you look above, you can see 192, 191, 130. That's showing you that that's what my IPs are. So if I do if config here, -a less, I have EM0 as 132. And then the other one is 130. Okay, that's what's confusing. Okay, 191, 130, 179, 132. This is where you get a piece of scratch paper. Okay, let me write that down. So this is something that when I was working at Foster's, we had to do rather frequently to keep the mainframe connected to the rest of the network. Because every time the mainframe had a hiccup of whatever, you had to add a static route to put it back on the network, because the networking that was involved with the mainframe was not TCP/IP. It was something else. And you had to create a static route and load the TCP/IP stack separately onto the mainframe so you could communicate to the enterprise stuff on the mainframe, so people could get to it by way of their web browser or whatever tool they were using to get to it. Okay, So doing static routes is not real common, but knowing how to do it is helpful. Okay, lets you route traffic. All right. So now let's see what I've got here. Let's see if I've got. Let's look at the web configuration on this guy just for fun. This is my web configuration is going to be on this IP address, 79.132. So let's go there. There it is. Let's hit refresh. See if it works. Is it talking to me? I think it's system. There we go. Interfaces. Assignments. See if it's going to say hello. Or did I kill it? It's trying to talk. Do I have to hit next? There we go. Oops, that's not what I want. I don't need their website. I want. Okay, it's thinking. Let's see if that talks to me. $132. It should talk. Let's see. Let's do 11. Restart configurator. Let's see if that helps. Well, isn't that frustrating? 132. The virtual machine. I've got my 2 network cards, and they're both connected. Host only and NAT, which is connected. And ping worked. I got out. But what I want to know is why can't I get to my web configurator? Maybe I didn't give it enough resources. Let's do this. We'll start over. Isn't this fun? Like I said, come watch me blow stuff up. Remember what promiscuous mode is? It's mostly for Wireshark and capturing traffic. There's other tools like T-Shark and TCP dump that work in that category as well. Okay. All right, we'll let this come alive. We'll go through some defaults here. And then maybe what I should do is probably use instead of using the command line, I should use the GUI. Because the GUI will probably have helps and explain things a little better. Because when I used this last, honestly, it's been a long time. It was all command line. So it's loading up all kinds of cool stuff. Gateway monitors, static routes, cron job, it's nice. DNS resolvers. When it says clock, you're usually using NTP as a network time protocol. Okay, there it is. We'll leave it there. And we'll go here, back to this one, and see if it. I wonder if I have a problem with this machine. If I put a second card in this one. No, I didn't. It's got the same. So it should be talking on the same. Too busy? How could it be too busy? Let's try it without HTTPS. $79.32. $79.32. Well, ain't this a bummer? Well, let's check something here. Let's one. Assign interfaces. So I've got WAN. Ping host. Let's see if I can ping itself. Don't you love it when demos don't work? Yep. Okay, so I can ping this one, and the IP address that I'm tied to here is 128. Let's see if I can ping 128. Oh, can't use the keypad, I guess. Num lock on. 79.128. Okay, I'm pinging. So I'm talking. Now let's see, just for grins and giggles, you know NetMap, localhost? Oh no, I can't tell if I'm running anything on NetMap, one of my favorite tools. The other one is SS. Oh no, what are we gonna do with SS? So you have to use netstat, and you use big old long flag, NETPAUL, to see what's open or not. Oh, that's right. BSD has different flags. Not. That doesn't work either. Okay. Let's do. So I want probably a uppercase L. Okay. So this is telling me which IP addresses and what is bound to what. So let's add a couple more flags here and see. Well, that didn't help. What I want to do is find out which network card my TCP IP is bound to. So I have C. Let's try C. Okay. So we have HTTP and HTTPS is bound to that IP address. So I should be able to get to it. But it's not. Let me try it from Windows. Let's see what happens here. I'm going to open a Windows and I'm going to ping it 192.168.79. That's what I was afraid of. It doesn't see it. How about 128? Oh. Well, folks, isn't that interesting? It shows it as having config EN0. Where, okay, there's my IP address. It's bound. I can ping it. So I can see my IP address and I can ping the other IP address. So I have connectivity between the two machines, but I can't connect the web interface from my other virtual machine to this one. Let's try this. I'm going to use Kali Live's browser because it's on the same physical network here. Isn't this fun? You can spend days working on stuff like this, especially when there's nobody around to ask, how do I do this? That's how I had to learn everything. I didn't have a choice. Yep, unable to connect, so I can't do it that way. So that's not working. So what this is saying is for some reason it's not connecting to port 80. So if I force it to port 80, still not getting there. It's just too busy. Oh well. How would you like to have a homework assignment on this one? So the reality here is what I'm trying to show you is the route add command so you can route traffic between two network cards. Okay. And I have a student in the finals projects class that is actually doing this sort of thing. He's creating an entire Active Directory domain in a virtual arena. And he's using Ubuntu, Windows 10, Windows 7, Windows Server. And for those of you who are interested in the operating system, what we have come to discover in the world of Windows and free stuff is they only give you a free stuff for, I don't know what it is, 6 months, 3 months. They don't have that program anymore where you can get free stuff for students that we know of. Okay. The answer to the question seems to be Microsoft wants to give you free stuff, but what they're going to give you free is Azure. So you'll be able to get free time on Azure to play with stuff. Okay. It doesn't look like we can get actual downloads of ISOs of operating systems that you install for free. You actually get them, you put in the key, and it's only good for 3 months or 6 months, depending on the product. That seems to be where they're going. And VMware is following that track as well. Okay. So on a side note, that's something if you want to consider. We don't have access to that anymore. That as far as we know. Okay. All right, let's go back to this and see if we can figure it out. So for some reason, it's pinging, but it's not talking. And if I look at EMP1, this is where I need to change it again. I need to change it to, let's do that. Let's type in exit and set interface to, and I want to change number 2 to 192.168. Let's make sure I don't use the same one. Okay. We have, oh, I need to drop my route. Silly me. 128. So 128, I do not want to use. I'll use 134, make it different. And it'll be a 24-bit subnet. For the upstream IP address, this is where I made the mistake. So my upstream address needs to be my other network card, which is 192.168.79. What was it? Darn. Anybody remember? I think it's over there. 32, that was it. 132. Your short-term memory, you kind of depend on. Okay. Enter, I don't need IP6. Do I want to enable DHCP? Not on this one because we're using fixed IP. And then, yes, let's use HTTP. Thank you. Maybe that's where our problem is. Now we should be able to get to, oh, it changed the, well, isn't that interesting? Oh. Did you catch that, folks? It says, look what it says, HTTP 192.168.191.134. That is the IP address I need to get to the configurator. Now, what's going on? What happened here? All right, let me explain. There it is. Oh, come on. Oh, I disabled HTTPS, so let's just do that. Oh, don't make a liar out of me. Diddle faddle. Okay. That's what it says. But anyway, what it's trying to do is I can only configure it on the LAN port, not the WAN port. The just like on your router, you actually have to open a security hole, a big hole, to configure the WAN, configure your router from the WAN. Okay. So I now have two IP addresses, 134 and 128, that are on the 191 subnet. So let's see if they talk. 191, 128. Would help if I put ping in there. We have ignition that way. 34. So we can ping self. That's good. Go to Kali. Let's see if we can ping self, which that should work. 4. Oops. 28. Oops, not 79, it's 191. Works. Now we'll go to 34. Works. Let's see if we can ping the IP address on, what I think it's 132. Exit. There we go. Yeah, 79, 152. Well, I can't get to that. Let's see if I can do this. Nope. and my default gateways are all messed up. So let's do this. System control status. We want networking service running. So let's stop it. This is like stopping and starting a service in Windows. Same idea. You can also use restart. Okay, now let's see what happened to if it kept my routes or dropped them. It should have dropped my route. It did not. Oh, I should probably, rather than do route delete, I'm just going to reboot because that's just stored in RAM. So I'm curious. I think I messed things up with the route add on the client because there's should be able 34. Well, isn't this fun? Well, 79, 132, 191, 134. Oh, I know. Okay, hold on. This would make a great final project. All right. So what I'm going to do, click on the browser here and see if I can get to the configurator, which was 192. Did it again. 192, 168. Ah, magic. All right, now before I do anything, let's look at what I got over here. So Ethernet 0 is back up. So let's bring Ethernet 0 down. All right. And see if we can ping 134. I'm going to predict it's going to work. Because of it connected via the browser. There we go. Admin. pfsense. If I could spell right. It's right there in front of me. pfsense. Okay. And system. Let's look at interfaces. So here we have our Mac and it shows the interface groups. Now, basically what you're doing is you are configuring pfsense just like you're configuring your router at home through a GUI. So this is actually a fun way to learn about higher end firewalls because there's all sorts of things you can do with these things. Like you can set up VLANs, wireless if you have a wireless card. So if you had an old USB wireless card, you could create a machine that is basically a router. You put in 2 network cards, take one network card, plug it into your hub for your house, for your wired computers, have a wireless card for your wireless devices, and then have one card that plugs into the wall that plugs into your service provider, Comcast or whoever, okay? And then all these fun things to go look up, okay? So assignments, groups, and let's take a look at, you got interfaces, you got firewall, that right there, traffic shaper, that is worth its weight in gold. That traffic shaper is, those things are, those are really sneaky. Traffic shapers used to be independent pieces of hardware. What it allows you to do is give some traffic priority, other traffic not so much. This is how Foster's got rid of people listening to radio over the internet, because it was slowing things down for normal work usage. So put in a traffic shaper and make the music get the very lowest priority. So it was all poppy and crackly and not working. And people stopped listening to the radio over the internet. Works pretty well. So you can do by queue, what kind of limiters you want to use, wizards, pretty amazing. And different services that you want to do. Oh, dynamic DNS, who do they got? Oh, wow, you got a bunch of them. So you can actually check your services. That's pretty cool. This is your network time protocol. PPOE, so if you're in Europe, you need PPOE to be able to connect out. Wake on LAN is how you can turn your machines on and off by hitting them with a packet from your, in this case, router. You can actually say, I want you to turn on. And you throw out a packet and the machine turns on. You have to enable Wake on LAN in the BIOS setting on your computer, okay? And this is cool. You have your own VPN server and you don't have to go buy a $600 router. And they're using OpenVPN, L2P, and IPsec. They're all very good, okay? And it shows you the status. Here's a dashboard. Let's take a look at the dashboard. Copyright, trademark. Yes, I accept. And hit close. So here's the dashboard of my pfSense. Basically, they give it away for free, but if you are using it in a commercial arena, you pay for support, and then you get good support. And that's the way a lot of open source has been maintaining their development costs, is by, we'll give it away for free, but then we'll help people when they use it in production when something breaks. And I think it's a good business model, okay? And it tells you what my BIOS is, what my domain I set up for, my LANs and WANs, memory usage. It's kind of like configuring your own router now. Captive portal. That would be worth something to read up on. What does the captive portal do? Go Google it. See what it does. Traffic graph. This is always fun. There's not much here. But what this does is it shows you what kind of traffic is going on and off your network. So in this respect, it's actually kind of nice, because this is, you can't do this on a Linksys router. I can't do this on my router at home. I can get logs, but I can't get real-time graphing like this. That's expensive stuff. And then diagnostics. Oh, let's look at my Arp tables. Here's my Arp tables. This is just, all I did was download the ISO, put it in a virtual machine, turn it on, and added a second network card. And look what I get to play with. Routes. Maybe this is what I need. Default gateway. Link to. This actually needs to be a gateway to that. So that's what I really need to do. I don't know how you do that. Maybe you don't. But technically, so if I ping network unreachable down there. But if I ping, that works. But if I ping the IP address of 79.132, it doesn't. So that means I need to put a gateway right here or something like that. Well, the other way to do it is just give it DHCP. I could do that. Fun. Oh, nice. Upstream gateway. That's what I need. 192.168. I need the IP address of the other card, which was 79. Do I need to put it on? Two of them. It's not letting me. Gateways can be managed by clicking here. That's what I want. Gateways. WAN. Okay, monitor. No. Still not there. Okay. I want to delete this one. Let's edit it. Well, this is where you got to play with it. I got to figure out what it was. It's all there. When I get this figured out, I'll do a screenshot of it. I'm sure it's really super simple. I'm just clicking on the wrong thing. Okay. All right. And I'm used up enough of your time. So that was a basic, like I said, crash and burn demo of things that of route add. I never did get to show you how it works, is where you can send traffic. You see, put two networks cards in a machine, one wireless, one not. You can have anything that is on the internet go out to wireless, And anything that's on your 192, 168 stay internal. So you can actually have it go out that way. But that was route add in all its glorious mess. So I will put some few notes together, and when the video is done recording, I will post it. I better turn it off right now. I'm thinking about it. Okay, screen share. I stopped the share. There we go. Now I can see the recording. All right.